This video is going to cover factoring polynomials using the grouping method. And we're going to start by using the area model. Now, if you remember with the area model, this model, you would have usually like your one factor up top, your other one on the side, and then you multiply the pieces to get the what goes in each box. And then you put all these pieces inside the box together to get your final answer. But we're working backwards. We're going to take our final answer, put it in the box, and then work to see what might have been on the outside of the box. So to get started here, I'm going to fill in the area model going in the same order of the standard form of my polynomial here. So I'm going to start with x cubed, and then 6x squared, 7x, and 42. And now we're working backwards. So if you think we multiply to get what's in the boxes, so we're going to factor to find what's outside of the boxes. When it comes to polynomials, those are kind of like opposites. So let's start with this first row here. I want to try to figure out what number or value, could have a variable, should go right here. And whatever it is, I know that both this piece and this term were both multiplied by this number. So in order to figure it out, I can just try to factor it out, kind of like factoring out a GCF. What would be the GCF of x cubed and 6x squared? I could factor out an x squared from those two terms, right? They both have at least an x squared. All right, let's try the same thing with the second row. How about 7x and 42? What's the greatest common factor between 7x and 42? And if you said 7, you would be right. We could factor out a 7 here because 7 multiplies, 7x is divisible by 7 and 42 is divisible by 7. Now, to figure out the top piece, you can also factor out a GCF, or you can use what we just found on the side to figure out what goes on top. So, for example, I know that x squared times the missing piece equals x cubed. Well, x squared times what equals x cubed? That would be times x. And we can check our work down in this square. Is 7 times x 7x? It is. So we can kind of use that to check our work as well. How about for the next one? We have x squared times something equals 6x squared. Well, that would have to be 6. 6 times x squared is 6x squared. But again, we can use it to check our work. We've got 6 and 7 that meet in this box, and 6 times 7 is 42. So that is correct. So now we just need to put our factors together. So on the left side, we have x squared and a positive 7. So we get x squared plus 7 as our first factor. And then up top, we have x and a positive 6. So x plus 6 is the second factor. Now at this step, we might be done, but you still want to check your factors to see if you can factor anything more. We have an x squared here, which maybe we could factor more, but it's not a difference, it's a sum. And so we do not factor sum of squares. And so we will stop here. This is our final factored form. Let's try another one using the box method. So I'm going to fill in starting with x cubed and then going in order. And I'm going to start by factoring out the GCF. I'll start with the first row. X cubed and negative 2x squared, their GCF would be x squared. All right, and now for negative 9x and 18, I could factor out a negative 9. All right, based on what I factored out here, let's find the missing pieces. X squared times what is x cubed? That would be x. And we can double check, is x times negative 9 negative 9x? Yes, it is. For the next one, x squared times what is negative 2x squared? That would be negative 2. And now let's check. Is negative 2 times negative 9 positive 18? Yes, it is. So we're good. Time to put our factors together. So for the left side, we have x squared minus 9. And then on top, we have x minus 2. Now at this step, remember, we need to check to see if we can factor anything more. And in this problem, we can. We have x squared minus 9, which is a difference of two squares problem. This factors to x plus 3 times x minus 3. And then we just bring down that last factor, x minus 2. If you think back to when we learned about the fundamental theorem of algebra, remember that these polynomials should have the same number of roots as their degree. And that's kind of a way you can also check your work and remember to bring maybe some of the factors down. My final answer here has 1, 2, 3 factors, and that matches the degree of 3. Now, in the previous problem we did, you might think that there's only 2 factors, but this one is x squared. So technically that counts for 2. So we have 1, 2, 3, which matches the degree of 3. Now, let's see if we could find a shortcut. Maybe you don't want to draw out the area model every time. So what we do, we set up our area model here. And then we always look for the GCF of the first row. Well, the first row is really the first 2 terms in this polynomial equation. So what I'm really doing, I'm doing x cubed minus 3x squared, and we're grouping them together. And then we're finding the GCF of 11x and negative 33. So it's like I'm, again, grouping these last 2 terms together. So we group them together, and then we look for the GCF for each group. So for x cubed and negative 3x squared, the GCF is x squared, okay? And we are left with x minus 3. Now, for the second one, I'm going to look for the GCF again. 11x and negative 33, that GCF would be a positive 11. And I'm left with x minus 3. Now, there is a little bit of a key to our shortcut, and that key is that when we factor out our GCFs, what we're left with in both of these parentheses has to be the same, okay? It has to be the same because that's what we would be left with when we factored out x squared from this line, or when we factored out negative 9 from this line, right? For both of them, we would be left with x minus 2. So it should be the same for each because we factored out x squared here, which if I do that, I'm left with x minus 3. And if I factor out an 11 down here, I should be left with x minus 3. Now, when I put this together, whatever the GCFs were, they make up one of the factors. Just like before, we had our GCFs that made up one factor. And then what's left over after we pull out our GCFs, that's what's up top, right? That is going to come together. That is just one factor, though. It's kind of like we're factoring that piece out. And then here is our factored form. Of course, check to see, can you factor anything further, but x squared plus 11 is a sum, so we cannot. Now, what's the point of factoring polynomials? It is so that we can then solve polynomials to find their zeros or the roots. So that's what we're going to do here. Let's start with this first one, and I'm going to use now our new shortcut. So the grouping method, I group together the first 2, and I group together the last 2. Looking for the GCF of x cubed and positive 3x squared, that would be an x squared. And I'm left with x plus 3. Then for the second one, we've got 2x plus 6. I could factor out a positive 2, and I'm left with x plus 3. Remember that these 2 must be the same, and they are, so we're good. Now, the x squared plus 2, the GCFs come together, and then x plus 3 comes together, and this is our final factored form. So I can write that again right here because it asks for it. X squared plus 2 times x plus 3, because we cannot factor x squared plus 2 anymore. Now we need to find the zeros, okay? And we can do so by taking our factored form and setting it equal to 0, because the original polynomial was equal to 0. And then, just like we did with quadratics, we set each individual factor equal to 0. So over here, we would do x squared plus 2 equals 0 and x plus 3 equals 0. And we'll solve these to find our zeros. So I'll start with the x plus 3. I'm going to subtract 3 from both sides, and I get x equals -3. That's one of them. Now for the other one, I'm going to subtract 2 over, and I have x squared equals -2. Now this is an x squared problem. How would I continue to solve this to get rid of the squared? I would have to use the square root. So I'm going to square root both sides. I get x equals plus or minus. Notice it's the square root of -2. So the square root of a negative, actually we could simplify that out to be I times the square root of +2. And these are the other two zeros. There's two of them, right? We have positive I square root of 2 and negative I square root of 2. Thinking back to the fundamental theorem of algebra, this polynomial is an x cubed, so we should have 1, 2, 3 zeros, and we do. Now we're going to plot these on the graph. So on this graph here, it's not really scaled. You'll have to scale it yourself. We have x equals -3. And then x equals I radical 2 and negative I radical 2, those are imaginary, so they do not show up on the graph. So we only have this one zero that's going to show up. Now, in order to really sketch these, the other piece that we need is just the ends. We can sketch it with just the zeros and the ends. So for the end behavior, remember we're going to start with the leading coefficient. Is it positive or negative? For this one, the leading coefficient was positive. That means the right end will point up. Then for the left side, we look at the degree. Is it even or odd? This one has a degree of 3, which is odd. That means that this side will point down. Then we play a game of connect the dots. We go from the left arrow, we go through the x-intercept, and then we go over to the right arrow. And that is a quick sketch of what this graph might look like. Let's try another one. Question 2. Oh my goodness, these are all numbered question 2. Oops, that's okay. So for question 2, the first one, we are going to start with grouping. So I'm going to group together the first two and group together the second two and look for the GCF for each group. The GCF for 12x cubed minus 9x squared is going to be 3x squared. When I factor out 3x squared, I'm left with 4x minus 3. For the second parentheses, the second group, we could factor out, well, notice this is 4x minus 3, which is what this is. So we don't have anything to factor out, but technically we have to factor something out. We have to do it. So what is something that I could divide anything by and it would still stay itself? That answer is 1. So we're actually going to factor out a GCF of 1 so that it stays 4x minus 3, which is what we want. But we have to factor something out in order for grouping to work. So now putting together, we have 3x squared plus 1 times 4x minus 3 equals 0. Our factored form here is the 3x squared plus 1 times 4x minus 3. And now we're going to solve to find our zeros. So I'll start with 3x squared plus 1 equals 0. And then we have 4x minus 3 equals 0. All right, with this one, I'll subtract 1 over, and I get 3x squared equals -1. Then I need to divide both sides by 3. I'm running out of room here. I'll go up here. X squared equals negative 1/3. And finally, I'm going to square root both sides. And we get x equals plus or minus I radical 1/3. So that's our first one. We've got I radical 1/3 and negative I radical 1/3. And then for the second one, let me move that over since I kind of ran out of room. I'm going to add 3 to both sides, and I get 4x equals 3. And then I'll divide by 4 on both sides and get x equals 3/4. And there's our last one, 3/4. All right, now to plot this on the graph, 3/4 would be somewhere less than 1, so maybe about here. And then the first two factors, or first two zeros, are imaginary, so they do not show up on the x-axis. Last thing I need is my arrows, so we'll start with the leading coefficient. Is it positive or negative? This one is positive, which means the right side points up. And then the degree, is it even or odd? This one is odd because the degree is 3. That means this side will point down. Now I need to just connect the dots here. We're going to go through the x-intercept. Make sure you cannot cross the x-axis unless it's through the x-intercept. And there's just a quick sketch of what the graph might look like. This might not be exactly what it looks like if you use Desmos. This next one here, this is 4x squared minus 69 equals 0. This problem is not a grouping problem. For this problem, we are going to use a difference of 2 squares, but I think that there might be a little typo here, so let's fix that real quick. I don't know where the 1 went. This should be 169, not just 69. All right, so we're going to factor this out using the difference of 2 squares. It will factor to 2x plus 13 times 2x minus 13 equals 0. So factored form is 2x plus 13 times 2x minus 13. But our zeros come from our factors. So we'll do 2x plus 13 equals 0 and 2x minus 13 equals 0 and solve both for x. So for the first one, I get x equals negative 13 over 2. And for this other one here, man, I keep writing over what I want to write. Oops. One more time. There we go. All right, for the next one here, we're going to add the 13. 2x equals 13, divide by 2, and x equals 13 over 2. So my zeros are x equals negative 13 over 2 and 13 over 2. Now, 13 over 2, that's about 6.5. So when we're putting it on the graph, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's going to be in there between the 6 and the 7. We've got both negative and positive. So we have our zeros. Now we need our leading coefficient. Degree. So first, starting with the leading coefficient, is it positive or negative? All right, so for this one, the leading coefficient is positive, which means the right side will point up. And then the degree, is it even or odd? This one, the degree is 2, which is even. So this side also points up. Now we're going to play connect the dots. So starting with the left arrow, we go through the x-intercept. Turn, we're going to go through the x-intercept and to the last arrow. All right, and our last one here, x to the 4th minus 13x squared plus 36. This might be a quadratic form problem. Since there's only 3 terms, we can try to use big X. So 36 would be on top and negative 13 on the bottom. I'm looking for 2 numbers that would multiply to 36 but add to negative 13, and that would be negative 9 and negative 4. In factored form, remember that because this is x to the 4th, my factors aren't just x minus 4 and x minus 9. It's actually going to be x squared minus 4 and x squared minus 9. And the trick is you can always look at that middle term to remind you of what the factor should have, if it's x squared or not. Now, we can continue to factor this because this is a difference of squares. So x squared minus 4, that factors to x plus 2 times x minus 2. And then x squared minus 9 would factor to x plus 3 times x minus 3. This is your factored form, of course, x plus 2 times x minus 2 times x plus 3 times x minus 3. But then when I set each one equal to 0 and solve, I'm not going to do each of these step by step. We get x equals negative 2, positive 2, negative 3, and positive 3. This one has 4 roots, and all 4 show up on the x-axis because they're all real. And that matches that this has a degree of 4. So 1, 2, 3, 1, 2, 3. We've got 2 and 3 and negative 2 and negative 3. Next up, let's find those end arrows. So the right side is the leading coefficient, positive or negative. This one has a positive leading coefficient. So on the right side, it will end pointing up. And then the degree, is the degree even or odd? This degree is even because it's 4. That means this side will also point up because they will do the same. Now we play connect the dots. I must connect the left arrow to the right arrow. I must go through every x-intercept, and I cannot create any extra x-intercepts. So I'm going to go from here through the first one. Then I got to turn and go to the second one, turn and go to the third one, and turn and go to the fourth one, and finally end up at the last arrow. There is a very rough sketch of what this graph might look like.